these solar panels made use of sunlight as a source of energy in order to generate DC electricity.
A photovoltaic module is a packaged, connected assembly of photovoltaic solar panels available in different voltages and wattages. Photovoltaic modules constitute the photovoltaic array of a photovoltaic system that generates and supplies solar electricity in commercial and residential applications.
Solar panels works by absorbing sunlight with the use of photovoltaic cells that generates DC electricity. That DC electricity will now be converted to usable electricity called AC electricity. With the help of inverter technology, the DC electricity will now be converted to AC electricity, which is also usable for homes and other industries.
History of photovoltaic technology. The PV effect was observed as early as 1839 by Alexander Becquerel and was subject of scientific inquiry through the early 20th century. In 1954, Bell Labs in the US introduced the first solar PV device that produced a usable amount of electricity, and by 1958, solar cells were being used in a variety of small-scale scientific and commercial applications. The energy crisis of the 1970s saw the beginning of major interest in using solar cells to produce electricity in homes and businesses, but prohibitive prices, nearly 30 times higher than the current price, made large-scale applications impractical. Industry developments and research in the following years made PV devices more feasible, and a cycle of increasing production and decreasing costs began, which continues even today.
What are the advantages of using solar energy? First, it is a renewable source of energy. Second, it reduces electricity bills. Third, it has diverse applications. Fourth, it has a low maintenance cost. And lastly, it is good for the environment.
In 2017, a group of researchers studied on how to absorb light in solar panels by using butterfly wings. The wings of a butterfly have inspired a new type of solar cell that can harvest light twice as efficiently as before, and could one day improve our solar panels. Sunlight reflected by solar cells is lost as unused energy. The wings of a butterfly are drilled by nanostructures that helps absorb light over a wide spectrum far better than smooth surfaces. Solar panels are positioned at an angle to get the most amount of light from the sun as it moves throughout the day. Thin film solar cells, which can be only nanometers thick, have a lot of potential. These are cheaper and lighter, but because they are less efficient, we usually use them only in watches and calculators instead of solar panels. The researchers from Calagui Institute of Technology, or KIT, have now succeeded in transferring the nanostructures to solar cells, and thus enhancing the light absorption rate by up to 200%.
Scientists led by Wadmano Sidakwe, a bioengineer at California Institute of Technology, looked at wings under an electron microscope and created a 3D model of the wings nanostructures to figure out why these butterflies are so efficient. The wings are built from tiny scales that are covered in randomly spaced holes. The holes are less than a millionth of a meter wide, and they help scatter the light and help the butterfly absorb heat. The holes are random in size, distribution, and shape. Using computer models, they figure out that the position and order are important for absorbing light. But the shape does not matter. After that, they created a similar structure using extremely thin sheets of hydrogenated amorphous silicon that have the same type of holes. Most solar panels are positioned at an angle, which means they generate lots of power for a few hours and then not much the rest of the time. Solar panels using this technique could produce more power throughout the day.